Hey math fans, welcome to the advanced problems of solving some absolute value inequalities. In this video, I'm going to solve an absolute value inequality that will be less than or greater than or some sort of sign compared to a linear equation. Something in the mx plus b kind of style. The important thing to distinguish when doing these is it going to be an or problem or is it going to be an and problem? So remember, if the absolute value is on the less than side of the inequality sign, then it is a less than problem, meaning it's an and inequality. And then if the inequality is on the greater than side, meaning it's being eaten by the inequality, then the absolute value is greater than the other side, making it an or problem. And when solving these for the second time, I always flip the signs on the non-absolute value side. I don't know if that's a rule per se that you always have to follow, but I know that I never get it wrong when I flip the sign on the non-absolute value side, and sometimes I will get the wrong answer if I flip the sign on the absolute value side. So just kind of one of those weird things. That it always seems to work out this way when you flip it on the non-absolute value side. So before I begin, I'm going to label this as an and problem. I basically mentioned it when I was talking about the and versus or problems, but the absolute value bars are on the less than side of this inequality. It is not eating the absolute value bars, so that makes it an and problem, if you want to think of it like that. If it's eating the absolute value bars, then it's an or problem. So once we get that identified, we're good to solve. So I'm going to do x minus 1.5 is less than 2x plus 3.5. I'm not changing anything except for the lack of the absolute value bars. So we'll need to get our x's to one side, so I can minus x to the other side, and I can also get my constants to the other side by minusing 3.5 over to the left-hand side. And so I get negative 1.5 minus 3.5 is negative 5. And that's going to be less than 2x minus x is x. So I have negative 5 is less than x. If you want to write that in the perspective of x, it'll say x is greater than negative 5. All right, so now I need to flip the signs and solve it again. And so I'm going to flip the signs on the non-absolute value side. So I'm going to keep x minus 1.5. You got to change the inequality sign. So it's less than, now it's greater than. And so now I have negative 2x minus 3.5. And so we're going to get all our x's on one side. So let's see here, since this 2x is negative, I'm going to plus it over to my left-hand side. And so I can also add 1.5 over to the right-hand side. And so x plus 2x is going to give me 3x. That's going to be greater than negative 3.5 plus 1.5 is going to give me negative 2. And so I'm going to divide by 3. And I'll get x is greater than negative 2/3. And so here I have my two answers. And I also know that it's going to be an and problem. So what I like to do is I like to graph both of my answers on a number line and then determine what my final answer will be based off of how the shading goes and whether it's an and or an or problem. Okay, so my first answer was x is greater than negative 5. So I'd put an open dot at negative 5 and I'd shade to the right. And then I got my second answer of x is greater than negative 2 over 3. So I put an open dot at negative 2 over 3, and I also shade to the right. So we said this was an and problem, right? So an and problem means both scenarios must be true at the same time. So I need to plug in an x value that's greater than negative 5 and greater than negative 2 over 3. So what exactly does that mean? Basically, since this is an and problem, they're true where they overlap, and they only overlap after it is greater than negative 2 over 3. they are not overlapping right here. So that scenario, if you were to plug in any number between -5 and -2/3, it would be false. Take the number -2. That's in between -5 and -2/3. If I plugged in -2 here, that would make -3.5. And then once you take the absolute value of that, it would make +3.5. Then you would take -2 and plug it in here. That would make -4 plus 3.5, which would make -0.5. So you'd have 3.5 is less than -0.5. That doesn't make sense. But take a number that is greater than -2/3, like the number 0. 0 minus 1.5 makes -1.5. Take the absolute value of that, turns into +1.5. Then 2 times 0 is 0, plus 3.5 is 3.5. So is 1.5 less than 3.5? Yes, it is. That's a true statement. So you can always test your answer here by just plugging in a number that should fit it. So my final answer is just x is greater than -2/3. So it's almost as if that x is greater than -5 doesn't really matter because this was an and problem and both scenarios need to be true in an and problem. So in this example, it is eating the absolute value bars. So that means the absolute value is greater than the other side. So that makes this an or problem, okay? So I'm going to solve 3x minus 5 is less than or equal to 2x plus 10. I'll say this about OR problems. Sometimes kids mess up on the OR stuff when you have an inequality sign that's OR equals to. So they don't pay attention to what side it's eating. They just see the OR equals to and they think it's an OR problem. Just because it has an OR equals to option doesn't mean it's an OR problem. If the absolute value side is greater than, meaning it's being eaten by the absolute value side, if it's greater than the other side, then it is an OR problem. That's the only thing that makes it an OR problem, okay? So back to this, I'm gonna get my x's to one side, so 2x is smaller than 3x, so I'll minus 2x to the left-hand side, and so that means I can add 5 to the right-hand side, and so 3x minus 2x is just x, and that'll say x is less than or equal to the sum of 10 and 5, so that's 15. And that's actually the final answer right there. X is less than or equal to 15. And so I will then drop the absolute value bars and solve it again, except I'll change all the signs on the non-absolute value bar side. So negative 3x plus 5, flip the inequality sign to greater than or equal to, and then you have 2x plus 10. All right, so since that 3x is negative, I'm actually going to add that to the right-hand side. And then that means I'll have to minus 10 to the left-hand side. And so 5 minus 10 is going to get me -5 is greater than or equal to 2 plus 3x is 5x. And so I'll have to divide by 5 for my final answer. And I'll get -5 divided by 5 is -1. So -1 is greater than or equal to x, or you could write it in x's perspective as x is less than or equal to -1. So at this point now I know three things. It's an OR problem, x is less than or equal to 15, or x is less than or equal to -1. So let's draw a number line here. So I'm going to have a solid dot at 15 that shades to the left, and then I'm going to have a solid dot at -1 that also shades to the left. And so since this is an OR problem, only one or the other must be true. So the overlap is actually not really important in an OR problem. If it were an AND problem, the overlap is super important. If it's an OR problem, then it only needs to be true with one or the other. So that means my answer starts from right there. So I'm going to get a true statement as soon as I get an x value that's less than or equal to 15. So that's the final answer there. Okay, so again, OR problems, overlap, not important. And problems, overlap, very important. So in my next example, I have the absolute value is on the less than side. How do I know that? Well, it's eating the other side. So therefore, the absolute value is less than the other side, making this an and problem. Think less than, right? So we're going to solve 6x minus 7 is greater than or equal to 2x plus 5. I can get my x's on one side by minusing 2x over to the left-hand side, and I can get my constants to the other side by adding 7 to the right-hand side. So I'm going to get 12 there, and 6x minus 2x is 4x, and I'm going to bring down that greater than or equal to sign, and don't forget to write your x. So we can divide by 4 on both sides, and I'm going to get x is greater than or equal to 12 divided by 4 is 3. And so now I can do the problem again, change the signs on the non-absolute value side. So 6x minus 7 turns into negative 6x plus 7, flip the inequality sign, 2x plus 5. And so since this is a negative 6x, I'm going to go ahead and add 6x to the right-hand side. I like to keep my x's positive when I can. And then I'm going to minus my 5 to the left-hand side. And so 7 minus 5 is 2, which is less than or equal to 2x plus 6x, that's 8x. Divide both sides by 8. And 2 over 8 can simplify to get 1 over 4. So I have 1/4 is less than or equal to x, which you could rewrite it as x is greater than or equal to 1 over 4. So I have 1 over 4. I'm going to put a solid dot there, and I'm going to shade to the right because it says x is greater than 1 over 4. And then I have a solid dot at 3 as well, and then I'm also going to shade to the right because it says x is greater than or equal to 3. And so now we just got to think, where does our answer become true? This is an and problem. So and problems depend on that overlap, right? So the answer starts at 3. So they're both true when x is greater than or equal to 3. For my final example, I have the absolute value of 12x plus 4 that is greater than 2x minus 4. So it is eating the absolute value side, so it is greater than the other side. Think greater, so it's an or problem. So we're going to do 12x plus 4 is greater than 2x minus 4. And I can get my x's on one side by minusing 2x to the left, and then I can minus 4 to the right, and let's see here, that's going to give us 10x, 12x minus 2x is 10x, which is greater than negative 4 minus 4 is negative 8, and so I will divide both sides by 10, and that fraction will be able to simplify. Negative 8 over 10, they both cut in half to make negative 4 over 5, so I get x is greater than negative 4/5. So now I can solve this problem again. I'll want to change the signs on the non-absolute value side, or the linear side if you want to think of it like that. So 12x plus 4 is flip the inequality sign, less than negative 2x plus 4. And so we can get our x's on one side by plussing 2x over to the side with the 12x. And then I'll have to minus 4 to the other side. And so 12x plus 2x is 14x. And then I'll have less than, and then 4 minus 4 actually cancels as well, making 0. So if 14x is less than 0, then x is less than 0. So I have my two answers, and I know it's an or problem. So let's look at the number line. If x is greater than negative 4 over 5, then it's going to shade to the right of negative 4 over 5. And if x is less than 0, then it's going to shade to the left of 0. So I have shading present on all parts of my number line. I have shading present in between here. I have shading present on the right-hand side and on the left-hand side. And this is an or problem. So in an or problem, the overlap does not really matter. Only one has to be true or the other, or they can both be true. So that means this answer is going to be all real numbers, or infinitely many solutions if you want to think about it like that. But the reason why it's all real numbers is because, like I said, the overlap's not really important. So it's true on anything less than 0. It's true on anything greater than -4/5. And it's true for anything in between -4/5 and 0. So it's one or the other or both. And so that means it's all real numbers in this case, since they overlap and pass each other, going left forever and right forever, and some in between. So I hope that makes sense. That's going to draw my notes to a close. Thank you for watching. Hope you learned something, and goodbye.